Okay, Dr. Erwin Neher. We have Dr. Erwin Neher from Max Planck Institute for Biophysical Chemistry, Nobel laureate. Thank you for being with us.
Well, it's a pleasure.
Okay, so your talk is on the 25th.
Yes.
With the title of Modulation of Short-Term Plasticity at a Glutamatergic Synapse. Could you tell us briefly about what your talk is about?
Well, short-term plasticity is an important phenomenon in the brain. Everybody agrees that the brain is plastic. Most neuroscientists are interested in long-term plasticity because that's believed to be the basis of learning and memory, But I think short-term plasticity is maybe not less important because it observes a number of basic signal processing tasks, like filtering, adaptation, gain control. Many things can be accomplished by neuronal networks which contain synapses which show short-term depression, And what I want to point out, first of all, that one shouldn't neglect it, And second, that there is some very interesting recent evidence converging from physiology, molecular biology, electron microscopy, that docking of vesicles and what we call priming, is not one direction and stable in the sense that a vesicle is primed and sits there patiently until an action potential arrives, but it's a dynamic process of priming, depriming, and in particular there is good evidence that the priming step is not single step but multi-step, And so I want to review some of this literature and then point out what I think is the physiological, the electrophysiological correlate of this multi-step dynamic thing. And in particular, then I will show a few slides of our more recent work on the calyx of health, which describes the process which we call superpriming, the fact that a fraction of release-ready vesicles is in a state of much higher release probability, release willingness than the rest of them.
I see. All right, thank you for your kind explanation. And my next question would be, if you have to compare 1991, when you first got your Nobel Prize, and 2019, which is now, in neuroscience, in your mind, what has been changed? And
what has been changed? Well, of course, during that time, all the molecular biology has developed, the genomic aspect has gained thing, and there has been optogenetics, which completely changed the field to the point that one may ask the question, is this old ephes still of any use, or, well, some people think it has degraded to an essay.
Oh, I see. I see.
Well, that's with respect to the way people do science. What also a major change is the rebirth of behavioral studies, and systems approaches, and that's of course a exciting development, because in the end we want to understand behavior. But I would like to warn that one should not jump too rapidly from a change in a protein from a knockout or a mutagenesis to behavior, because there may be big things in between, which are not understood.
Yeah, that's a good point, because I was going to ask, from that perspective, how do you envision short-term plasticity would contribute in terms of understanding behavior?
Short-term plasticity, well, I think short-term plasticity, and particularly this phenomenon of balance between primed and superprimed states is important for relatively rapid changes which occur. I mean, we know that one can define certain brain states, arousal, sleepiness, attention, you know, during sleep, the rapid switching between REM sleep and other forms of sleep. And these changes cannot be due to LTP or LTD, you know, they need to, or most likely are changes in short-term plasticity. And one thing I also want to show is that at this superpriming phenomenon, you know, can change a synapse from showing facilitation to depression. And